Hello everyone. Today we're going to be looking at how to sketch a parabola from factored form. Now we had already spent quite a bit of time looking at transformations of parabolas and being able to sketch parabolas from transformations. But now we're going to be looking at how to do it from factored form. And the reason is because if an equation is given to you in standard form, it's better to be able to factor it to graph it than it is to find the transformations. It's actually quite a bit more difficult to figure out how to go from a standard form equation to a vertex form equation than to go from a standard form equation to a factored form equation. So that's why you need to be able to do this. And one of the first skills you're going to need is to be able to find the roots or the zeros of the equation that's in factored form. So we're going to start by just looking at that one part. How do you find the roots or the zeros when you're trying to factor to graph a parabola? So the first thing I'd like you to notice is we have our first equation here. Y is equal to 5x times x minus 4. What are roots or zeros? What is that? So let's start there. If I give you a graph of a parabola, parabolas have very specific characteristics. These 2 points right here are called the roots or the zeros of the parabola. I like to call them the zeros, but textbooks will use both of these words, so I'm going to try to remember to use both of them as much as possible. There's also an axis of symmetry. Because a parabola is symmetrical. And there's also a vertex. Now, the zeros, or the roots, as you can see, are an equal distance away from the axis of symmetry. And that means that the vertex is smack dab in the middle of both of those zeros or roots. And that's basically the logic behind how we're going to sketch parabolas using factored form. We're going to find the zeros, we're going to find the middle of those two zeros, and then we're going to calculate the vertex. So that's why it's so important to be able to find the zeros, because if you can't find the zeros, you can't find the vertex. So how does this relate to the equation? How do I find those zeros? Well, it's all based on the fact that the zeros cross the x-axis. And any coordinate that's on the x-axis has a very special property. If I was to write the coordinate of that zero, let's say it's at, 3. Let's say it's at 4, 0. This one would be at -2, 0, let's say. All right? Look at what both of their y coordinates are. Both of their y coordinates are 0. Now, one of the most difficult things for students to understand in mathematics is that the equation of a graph is exactly the same thing as the graph itself. So if all our points that cross the x-axis have a y value of 0, that means that our y value in our equation should be set to 0 to be able to link itself to those two specific points. And that's how we're going to find our roots or our zeros, is we're going to set our y value in the equation equal to 0. Now let me be clear about something. This is not the parabola of this equation. I was just using a random parabola here just to show you what the zeros are, the points that cross the x-axis. But this is not the equation of that parabola. All right? So we're going to set our y value equal to 0. The rest of the equation stays the same. And then we're going to use some logic to figure out how would y equal 0? So what x values would make the equation equal 0? Well, we know that if you have a blank times 4, and that was equal to 0, what would the blank be? What's the only number multiplied by any other number that equals 0? And the answer would be 0. And we're going to be saying 0 a lot, by the way. It's a word that comes up quite a bit in this lesson. So a blank times a number, or a blank times a bracket, if we're trying to figure out what that blank is, but we know that the equation equals 0, that blank has to be 0. Okay? Well, that's the logic we're going to use to solve for this answer. We have two things multiplying. We have the 5x multiplying, and we have the x minus 4 multiplying. Okay? So this is like saying blank times x minus 4 equals 0, or 5x times blank equals 0. So what does the blank have to be? The blank has to be 0. That means that we're going to separate both of these things. We're going to say 5x, and we're going to set it equal to 0, and we're going to solve for x, and that's going to give us our first 0 or root. Now this one's really easy. How do I get x all by itself? I'm going to divide by 5, but if I divide 0 by 5, the answer is just 0. So that is my first root. Okay? Then I'm going to take my second thing, the second blank, and I'm going to make it temporarily equal to 0. Let's solve for x. How do I get x all by itself? Well, how do you get rid of a minus 4? You get rid of a minus 4 by moving it over to the other side, and it becomes a plus 4. And this is my second root. And that's how you find your roots. You take your factored equation, you split it up as the two things that are multiplying. You've got 5x that's multiplying, and you've got x minus 4 that's multiplying. Make them separately equal to 0, and solve for x. Now, I'm going to be showing more examples of this in the actual examples of how to factor an equation, find the zeros, find the vertex in order to find the sketch of the parabola. A little bit of foreshadowing here. If you know that your two roots are 0 and 4, can you find the middle of those points? I like to call it x mid for x middle, and I think it's pretty easy for everybody to see that the middle would be 2. So we'd already know where our parabola crosses the x-axis. So this parabola crosses the x-axis at 0 and 4, sorry. We know that our axis of symmetry, which is the middle, is at 2. The only thing we don't know is where the vertex is. So we'd still need the vertex, and I'm going to switch slides and start explaining how we're going to do all of that. So the first thing I'd like you to have in the note that I'm going to post for you is the list of steps that you would follow in order to sketch a parabola by common factoring. So you might not understand all of these steps yet, but I want them to be the first things you see in your note, so that when you're rereading your note to study, or if you need it for next year, you will have that list first, and hopefully you'll remember those steps after I've shown you the actual example. So the steps we're going to follow are we're going to factor our equation. We're going to find the roots and the zeros like I just showed you on the previous slide. We're going to find the middle of those points like I just showed you on the previous slide. And then we're going to substitute the middle value into the original or factored equation to find the y value of the vertex. So that's the step that you don't know how to do yet. Once we've done that, we'll be able to sketch our parabola. So let's look at this example here. I want you to sketch y is equal to 2x squared minus 8x. So I've started to list the steps on the side here. Let's follow the steps. So the first thing to do is to factor this equation, which is the lesson that we had previous to this one. So how do I factor an equation? I have to find the greatest common factor. Well, the greatest common factor in this equation, what can 2 be divided by that 8 can also be divided by, and is the biggest number that both of them can be divided by? Well, 2 and 8 can both be divided by 2. X squared and x have an x in common because both of them can be divided by x. So our greatest common factor is 2x. So what is our factored form? Our factored form is 2x times, now what are the leftovers when I divide 2x squared by 2x? My leftover is x. What is my leftover when I divide 8x by 2x? And it's a negative 8x by 2x. It is negative 4. So I have now factored my equation. Let's now find the zeros. So as I just showed on the previous slide, we're going to set y equal to 0, and this is a temporary thing. Y is not always equal to 0. Y is only equal to 0 in this step. Let's split up the two things that are multiplying. And we're going to separately make both of them equal to 0. Then we're going to isolate for x in both of them. Well, this one's very easy. We're going to divide by 2. Now, I normally don't even show that step for these ones because it's just going to give 0. 0 divided by 2 is 0. What happens when I isolate for x here? Well, the minus 4 goes to the other side and becomes a plus 4. And now our next step is to find the middle. Well, what is the middle of 0 and 4? We know that it's 2. In fact, it matches the example I showed on the previous slide. Coincidentally, it's not always going to be 2. But what happens if the numbers were like a lot uglier than 0 and 4? There's actually a formula for calculating the middle. And the formula is add both numbers and divide by 2. And that's going to give you the middle point. So if we add 0 plus 4 divided by 2, we get 2. And I like to call that x mid because it is an x value, but it's the middle of the 2 points. So what do we know already? We know that my parabola has a 0 or a root at 0 and 4. We know that the axis of symmetry is at 2. What I don't know is the parabola a smile or a frown shape? I don't know that because I don't know where the vertex is. But as soon as I know the vertex, I'm going to know the exact shape of that parabola. So that's the next step, is how do I find the vertex? Well, the vertex is a y value. Now I'm going to do one thing before I switch slides here. I'm going to need this equation. So I'm just going to copy it so I can bring it to the next slide. So we need to find the vertex value. Well, like I was saying on the previous slide, the vertex value is a y value. So how do I find a y value in an equation? Well, the y value is the first letter in the equation, right? So I need to calculate that y value. But I can't calculate the y value unless I know the x value to substitute in. Well, which y value are we looking for? We're looking for the y value of the vertex. So which x value should I substitute in? I should substitute in the x value of the vertex. But we just calculated the x value of the vertex. That's our middle point. This middle point is the x value of the vertex. Now, why is that? Because the middle point is the axis of symmetry, and the vertex is always on the axis of symmetry. So this x value is the x value of the vertex. We just need to substitute that into the original equation. Now, you can actually use either equation. You can use the first equation or the second equation. I much prefer using the second equation than the first one, but I'm going to prove to you that it doesn't matter which equation you use. We're going to use both, okay? But you only have to use one. So we're going to sub in the x middle, okay, which is 2 in this case. So what do I get when I sub in 2 over here? Here's how I like to do it. I'll actually write out the entire equation, but I'll put brackets where the x's are, and then I'll just put a 2 in to those brackets. So what do we get with that one? We get 2 times 2 squared, which is 2 times 4, minus 8 times 2, which is 16. 2 times 4 is 8. 8 minus 16 is negative 8. Over here, we're going to do the same thing. Wherever there's an x, I'm going to put a bracket. And you don't absolutely have to follow this way of doing it. I just like to do that to help me organize where the x value is going to go. And what do we get? Well, following BEDMAS, 2 minus 4 in the bracket is negative 2. And on the outside here, we have 2 times 2, which we can actually do at the same time because we're not affecting anything inside that bracket. So 2 times 2 is 4. What's 4 times negative 2? It's negative 8. And we got the exact same answer as the original scenario there, okay? So what is that negative 8? Well, that is our vertex y value. So I now know that my vertex is at 2 for the x value, which was our middle value, and negative 8, which is our y value of the vertex that we just calculated. I also know that my two zeros, or roots, are at 0, 0, and 4, 0. Because we got, if I go back one slide here, when we were finding our zeros, we found that x equals 0 is one of our zeros, and x equals 4 is our other 0, right? Well, those coordinates always have a y value of 0. So 0 is the first root, and 4 is the second root, and this 0 is just because it's on the x-axis. So with those 3 points, we can now get a pretty accurate sketch of our parabola. Actually, I gotta move that up a little bit. Because of where our vertex is going to be. Okay, so let's plot our points. 0, 0, 4, 0. I'm going to draw in the axis of symmetry. Let's put the coordinate of our vertex. So the axis of symmetry is right on 2. I'll write in the 4 and the 0 here as well. So 2, negative 8. So let's say negative 8 is way down here. I'll put a point there as well. And now, and this is always the hardest part, is sketching the parabola. So what I'll do, and you probably should do the same thing, when you're sketching parabolas, it's actually easier to start at the vertex and just aim for the root. And there's our parabola. And I know that might seem like a lot of steps. It really isn't. I just had to explain everything for this first example. It actually goes a lot faster than that, and I'm going to prove that to you on the next example. So let's say I ask you to sketch y is equal to negative 5x squared plus 15x. Okay, so the first thing I want you to notice is this is not in vertex form. This is in standard form. When things are in standard form, the first thing we're always going to try to do is factor. All right, so I'm not going to list the steps out. I'm just going to do the work to show you that this is really not a lot of work. So the first thing we're going to do is factor. Now this is a negative 5 and a 15. What is the greatest common factor of negative 5 and 15? It is a negative 5. We have to take the negative out because as I explained in one of the previous lessons, whenever your first term is negative, you really should factor out the negative as well as the number. So both of them are divisible by negative 5, and they both have an x in common. So that is my greatest common factor. What is my leftover when I divide negative 5x squared by negative 5x? I have a leftover of x. Dividing 15x by negative 5x gives me a negative 3 left over. What's the next step? Split up these two. We're going to temporarily make y equal to 0. Which I'm just going to write like that, okay? So I don't have to rewrite the entire equation. And then we're going to say negative 5x equals 0. And x minus 3 equals 0. Remember, we're doing that because the logic is either one of the things equals 0 so that they multiply to give 0 for the y, or the other thing equals 0 so that they multiply together to give the y equals 0. All right? So this one's easy because it's just negative 5 times x. We're going to divide by negative 5, but anything with a 0 divided by a number is going to give 0. Please note, we're not dividing by 0. Some students get confused here. We're not dividing by 0. We're dividing 0 by a number, and that works. That gives 0, okay? Here, we're going to isolate to get our 3. And then what I usually do is I'll just do these two little lines to show that I'm now finding the middle of those 2 points. Well, what's the middle of 0 and 3? Now, this can happen. 0 plus 3 divided by 2 equals 1.5. So we're getting a decimal answer, and that's okay. That can happen, all right? So what do we do with that x middle? We substitute it back into the original equation, and I like to use the factored version of that original equation. So we're going to go back to y. Y is no longer 0. Remember, that was just a temporary thing to find our two roots. Now I'm going back to the original equation. I'm going to substitute 1.5 in for all of the x's. So 1.5 goes here, 1.5 goes there. And the following bedmass, 1.5 minus 3 is negative 1.5. What is 5 times 1.5? I believe that's 7.5, so this is negative 7.5. Let me just double check that on a calculator off to the side. I'm pretty sure that's correct. Yeah, so it's negative 7.5, and I'm going to need my calculator again to calculate the final answer. So negative 7.5 times negative 1.5 is going to give me 11.25. Which is the y value of the vertex. So let's put all of our points together. We're going to summarize by saying our vertex is where? Well, what was the x value of the vertex? The x value of the vertex was the middle, which is 1.5. The y value of the vertex is 11.25. What are my roots or zeros? Those were our two numbers that we got here, which was 0 and 3. So the coordinates of those points are therefore 0, 0 and 3, 0. Let's plot all of those points. Now I want you to notice that the vertex is positive this time, where it was a negative number on the previous one. So how is that going to affect the graph? So we've got 0, 0, 3, 0. I'm going to draw my axis of symmetry, smack dab in the middle. That's at point 1.5. And then at 11.25, I'm going to put another point. And we now have our parabola. And that's it. And if you look at how much work, that's not a lot of work. It's like 5 or 6 lines of work there. Okay? Now I want to show you one little thing about what can sometimes happen when you're finding roots or zeros. So let's look at this one. If I ask you to factor to find the zeros here, or to sketch the parabola, okay, what is the greatest common factor to 12x squared and 8x? So both of those are divisible by 4. They're not divisible by 8, because this would have to be 16 or something like that, but they're both divisible by 4, right? So the greatest common factor is 4x. So if I take that 4x out in front, what are my leftovers going to be? Well, 12x squared divided by 4x gives 3x. And 8x divided by 4x gives 2. Now, this is the first time, I believe, that we're seeing a number appear in front of the x in the bracket, at least for the zeros. It might have happened in some of your common factoring homework, but this actually changes things just a little bit, and I'm going to show you how. So if I ask you to find the zeros, right, you're going to make y equal to 0. You're going to split these off and write both of them separately equal to 0. Nothing changes over here. This is just going to become 0. But something changes over here. You're going to end up with 3x equals 2 to isolate x. But then we have to destroy the 3, which means bring it over to the other side. And since the 3 is multiplying, it's going to divide. So we end up with a fraction here, which actually is a decimal value, right? And that can happen. So when you're finding your middle value, you would do 0 plus 0.67 divided by 2. So you're going to end up with some ugly decimals. But you have a calculator, right? So you should be able to deal with this. So I think that pretty much covers everything you need to know. I'm not going to continue this example off. It'd be a great example for you to do in practice. But that's how you factor to find your zeros, to find your middle, to find your vertex, and then to sketch your parabola. So that is the end of the lesson for today. Expect some work to follow, and we will talk to you again tomorrow.